everyone, let's begin in the series of Jamovi. One more test, that is Kruskal-Wallis test. And Kruskal-Wallis test, again, it is a non-parametric test. So where we, in which condition we would apply Kruskal-Wallis test when our data is not normally distributed. If our data is normally distributed, then we can apply one-way ANOVA, right? It is a replacement of one-way ANOVA, but when our data is not normally distributed. When data is normally distributed, definitely we have to go for one-way ANOVA. When data is not normally distributed, we will go for Kruskal-Wallis test. So Kruskal-Wallis test provision is also available in Jamovi. So today we will run and we will compare those are the results coming after running this test with the SPSS test also. So Kruskal-Wallis test allows possible difference between two or more groups to be examined and is equivalent to one-way ANOVA between the groups. So what is happening? Which example? Same example I'm going to carry. That same example I had explained you when I have run one-way ANOVA with the help of SPSS. So same example I would run. The Vice President Sales has developed 3 new training programs for increasing sales effectiveness. So there are 60 new hires in the organization. He has randomly chosen 20 people for each training program. After 1 year, he decided to see the results. So due to violations of the one-way ANOVA assumption, that is why we are going to apply Kruskal-Wallis test. So now we can see total how many? 20, 20, 20. So there are total entries are 60, right? First 20, it is representing training program number 1, right? Second one, it's reflecting training program number 2, and 3 is reflecting training program, third training program. And these are the sales output, right? Sales in lakhs. So we want to check, this would be our hypothesis, right? Whether there is any change, any difference among all these 3 training programs, or all the 3 training programs are same, right? So what we have to do, simply these are my results of SPSS, and now we can say which one is got the like mean rank highest, first and second, and all these things I had explained over here. And whether this one is the interpretation of this, I have already written the chi-square value. That is, we can say degree of freedom 2, and total number of, those are the observations are 60. And this one is the, because significance level that is less than 0.05. So it is indicating that sales differ significantly across 3 training programs. So the second training program delivers maximum good results, and it followed by the third training program, and first training program delivers the least favorable results. Means if we are comparing all 3 programs, so very good finest results we have received from second training program, right? So now what we have to do, we would run the same data in Jamovi. Let me open this file. First of all, we would load this file, open this file, and this one is the SPSS file I'm going to upload over here. Kruskal-Wallis test, right? So Kruskal-Wallis test, this file is open. And there is, you can see there are 3 categories: first training program, second training program, and third training program. And this is the sales, right? And we can check, there is descriptive statistics also. First of all, I'm sure we must go for descriptive statistics, right? And for this program, you can check frequency, right? And I would check this. And now you can see this is the frequency. First training program, 33 point. This one is the 2020 counts in each program, right? And there is the descriptives. We can see mean value, median value. This is for the sales, right? Because sales is, we had observed at continuous scale. And further is, we can check what we can check here, plots. We can check box plot also for this. So box plot, moment we have to check box plot, I'm sure there would be some outliers. So let me check. Yes, 56, 36, 35, and 37. These are our outliers, because this data, that is why it is not normally distributed. So here is what we have to do, and other things also we can check. Let's say, not this one is also, you can see these are all our outliers, and that is, we can check QQ plot also. See, you can see This data is not normally distributed. That is why we are going for this Kruskal-Wallis test. Otherwise, we can apply ANOVA. And what other tests we can check? Normality, yes. Shapiro-Wilk test also. So what is reflecting, right? That is also the same. Shapiro-Wilk test, that is also same. That is less than 0.05. So means there is data is not normally distributed. Fine. So we will go ahead. First, we will select this ANOVA. And here is when our data was normally distributed, we had applied one-way ANOVA. Right. But here in this condition, our data is not normally distributed. That is why there is a categorization in non-parametric test. So what I have to do, I will apply one-way ANOVA Kruskal-Wallis test. A moment I had selected Kruskal-Wallis test. Now we can see, and sales is our dependent variable and grouping variables are programs, because we have three training programs, training program 1, 2, and 3. And now we can see this is the p-value less than 0.01, means we can say I'm just copying this data and I would compare what my SPSS results I have received. So let me, I just want to give you some more interpretation. That session would be wonderful session. So you can, I'm just putting up my, so same results. There is no difference. These results I have received, those are the yellow one. These results I have received from SPSS, and these results I have got through Jamovi. This is the, both the results are exactly same, right? Now we can come to the interpretation. So obviously interpretation will be same. There is the difference among all the three training programs, and this training program is the best, right? This one is the second one is the best, then the at the second place, third one, then the first one. So now, furthermore, we are going to study effect size also we have to check. This is the effect size. I will give you one way ANOVA effect size, how we are going to interpret. Right, you can see, and DSCF pairwise comparison also. Right, was still this one is the pairwise comparison. That's the important. But in our case, if you would see first training program, that is also below 0.5. Right, first in between first and second. When we are comparing first and third, that is also below 0.05, and second program and third training program, that is also below 0.05. That means all three training programs is entirely different. So how we are going to interpret? So your reported epsilon squared, that is in my case, this epsilon square, we can just highlight this. This one is 0.344. What it is representing? What is the interpretation of this? Represents an effect size for the Kruskal-Wallis test. It indicates how much of the variability in the dependent variable is explained by the independent variable. Right. So how much dependent variable is varying by the independent variable? In our case, independent variables are training program. We have three training program 1, 2, and 3. Right. And this one is the our dependent variable is our sales. That means training program is how much is influencing this sale. And interpretation, when we, how we are going to interpret a small effect, if this value, right, epsilon squared value, it is less than 0.01, then we can say small effect. But when this value, it is less than 0.06, we can say medium effect. But when it is greater than 0.14, that is large effect. In our case, this value, it is greater than, we are falling in this category. Large effect. Why? Because our value is 0.344. So I would say I can interpret, since 0.344 is well above 0.14, it suggests a large effect size, meaning that the independent variable has a strong influence on the differences between groups. Then we come to the, this one is the, since the Kruskal-Wallis test only tells you that there is a significant difference somewhere among the groups, but it does not specify where the differences lie. So that is why we have run post hoc test. And I will show you same thing. These are the post hoc test, DSCF pairwise comparison. This is actually post hoc test. Let me copy this. and we are going to paste it here and then post hoc test. Let me come down on the next page and we will paste here. So it is reflecting all these programs are, there is a significant difference between first and second. First training, let me highlight all these from different colors. So I'm sure comparison, pair-wise comparison, we can understand. And let's come to the, this one is, that is not blue, that is green. And alphabet should be black. Okay. Let me. Right. So second training program, third training program. Now, how we are going to interpret post hoc comparison for Kruskal Wallis Duns test with von Ferroni, Holm, and these are the, or Benjamin, these are the tests, those are the widely used for non-parametric post hoc tests to determine which specific group differ from each other. So pairwise, and this one is the pairwise Wilcoxon ransom test that we are calling, another name is Mann-Whitney-U test with correction. So used for pairwise comparison, adjusting for multiple testing. So this is reflecting a pairwise comparison after post hoc and what is the relevance of the Kruskal-Wallis test, that I'm sure this video would be helpful. So stay tuned and keep watching. Thank you.